Okay, then we move on to do the revision exercise. We have to open file number 5, again using the 2017 community survey. So let's open file number 5. Okay, we can go through the variables. Okay, unique household number, person number. I think this time it is a person level data set. Let's do a summary combine. So it's 800,000, more than 800,000 people taking part. Province, race, gender, age, relationship. I think relationship represents whether you are the household head, you are the spouse of the household head, and so forth. Let's do a tabulation. Yes, this is the relationship variable. Marital status, I think self-explanatory. Education years, educate, employment status, total number of employees in the household, and then some non-income welfare variables, ownership of computer. I think there's something wrong with the description actually. It's the wrong way around actually. Computer ownership, television, landline telephone, mobile phone, household size, which means the total number of members in the household, and then the household income. So let's look at the actual data. Okay, since this is a person level data set, then it means all the people from the households took part in the survey, and then the people from the same household, they would have the same unique household number. So for instance, if we look at the first 3 rows, you can see person number 1, 2, and 3, they come from the same household. This is why they all have the same unique household number. And I think the household size should be equal to 3. Let's scroll rightwards. Indeed, household size equals 3. And you can even identify the first person is the household head. Usually for the household heads, Stats SA would allocate a person number of 1 to the household head. And then you can see the age is quite a youngster, actually 23 years old. Okay. So I think we can move on to do the actual revision exercise. It is actually a very long revision exercise, testing all the knowledge you learned from the last 2 dates. First one is straightforward, per capita income. We know it stands for total household income divided by household size. Okay, so let's do that. The generate command, generate per C. Remember that was my preference earlier, nominal personal disposable income equals total household income divided by household size. Okay. And then if time permits, give a short description. Nominal per capita income. Okay. I suppose by now you should know how to label a variable. It is a really easy task. Next one. Real per capita income in 2016 constant December prices. You are given the CPI at the time of 2007 community survey. It was 54.9. So let's derive the real per capita income. Generate real per C. Real per capita income equals the nominal per capita income we derived just now, divided by CPI, which is given, times 100. Okay. Then I can give a description. It stands for real per capita income. Okay. Okay, next one. Log real per capita income, same old story. Oops, same old story. Generate log real per C equals log of real per capita income. I think we did a similar question from the other exercise earlier. And then label variable log real per C means log real per capita income. Okay. So we have generated 3 new variables in the dataset. Okay. Next one, just to test the knowledge you learned early on the descriptive statistics table. Derive mean real per capita income in each race. Okay, statistics. First option, third option, first option. Okay, real per capita income by race. I want to derive the mean. Okay, 2321 2.66. Let's check I did it right. Okay, 2321 3.66. So this is the national mean, just above 40,000. Okay. Okay. I think you would know how to interpret the answers. Okay. And then 9.5 simply asks, can you do a bar chart on your results from 9.4? So this is a vertical bar chart. Okay. So we go to graphics, bar chart. Okay, vertical bar chart, mean of real per capita income. That's not the log. I just want to double check. Okay, yeah, not the log one. And then over race. Okay. It will take some time because the sample size is big. Remember, it's more than 800,000. Okay. Happy with that? Next one. Okay, the two-way crosstab descriptive statistics. I want to derive the mean real per capita income by gender in each race group. So race and gender, and I want to derive the mean of real per capita income. Okay, first option, third option, and third option. Race, gender, the summary variable is real per capita income, but I only want the mean. I'm not interested in standard deviation. I am not interested in frequency, and I'm not interested to know the number of observations, except I'm interested to know the mean. Okay. Okay, 24825 something. Let's check I did it right. Okay, that's fine. Okay, I think you would know how to interpret the results. Okay. Okay, next one. Okay, horizontal bar chart on what you did in 9.6. So horizontal bar chart on mean real per capita income over gender over race. Okay, so let's go back to graphics. Bar chart. This time horizontal. It is still the mean of real per capita income over, I forgot how it looks, over gender and over race. Over gender, over race. Okay. Again, we must be a bit patient because the sample size is big. Okay. So if you interpret this graph, it means on average, the white male individuals earn the highest. Okay. Okay, box plot. Okay, on years of education and log real per capita income over race. Okay, so just a reminder for the box plot, you can include more than one variable. So in this case, there are two variables. Okay, so graphics, box plot, two variables, years of education, not the educate, but the years of education, and then log real per capita income over race. Okay. Box plot is more time consuming. Okay, so we need to be a bit patient. You see, Stata is busy making progress to generate a chart. Okay, still in progress. I'm not sleeping. Okay, I'm waiting for the graph to be generated. Okay. I think probably these outliers, they are the culprits causing Stata to take so much time to generate a box plot. Okay. Done. Okay. Okay, next one. This one is the easiest one. Correlation coefficient between years of education and log real per capita income. Let's see if we would derive the same answer, 0.3106. So the keyword is correlate. Years of education. Is it a log one? Log, yes, log real per capita income. Yes, 0.3106. So positive, but not a particularly strong relationship, but at least the direction is correct. Positive relationship, conforming to economic theory. I suppose you remember the human capital theory. The more educated the person is, the higher the earnings. Next one, pie chart on racial composition by province, but I'm only interested in two provinces, Western Cape and Eastern Cape. So I need to type something under the if box. Graphics, pie chart, racial composition by province, but there's a restriction. Yeah, by province, the if box. If province is between 1 and 2, remember province 1 stands for Western Cape, 2 stands for Eastern Cape. Okay. 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 You clearly see the racial composition differs a lot across the two provinces. In the Western Cape, the colored population is most dominant, I think close to 60%. And then in the Eastern Cape, it is the African population that is most dominant. I think it's around 80 or 90% actually. Okay. Next one, histogram on age. I think we need to first find out if age is a discrete or continuous variable. So let me tap the age. Okay, all in integers. Okay, no decimal places involved. So it is a discrete variable in the dataset. You can see the restriction. Only include people aged 0 to 99 years old. And then the width of each interval is 10 years. And also include the normal distribution line in the graph. So let's do graphics. Histogram. Discrete variable. Age. Width of the interval is 10. Theoretically, minimum is 0. Y-axis, percent. I need to type the restrictions here. Age must be between 0 up to 99 years old. So in other words, we exclude people older than 99 years old. And then the density plot, add the normal distribution curve.